Hi, we're on video 8, hopefully our last video. In preparation for task 1, we're going to find stationary points, which we did at the end of the last video. But this time we're going to determine their nature, and we're going to try and have time to sketch the curve, so we're ready to get going. Okay, now to find stationary points, we find the first derivative, we make that first derivative expression equal to 0 for stationary points, we solve it to find our x values, and then we sub those x values into our original equation, which is our y equals equation, to find our y values of any points of any stationary points, any turning points. Now to determine their nature, we find the second derivative this time, and we sub each of the x values that we found into that second derivative expression, and if those x values make the second derivative greater than 0, we've found a minimum turning point. If our x value might make our second derivative less than 0, that means it's a maximum turning point. And if our y double dash is equal to 0, then it's what we call a possible point of inflection. And as you know, we must check y double dash either side of that point to see if our concavity has changed. Quite a process, but you'll get the hang of it with enough practice. And speaking of practice, here's an example we could use. Find stationary points and determine their nature on this particular curve. Y equals x cubed minus 3x squared minus 9x plus 2. Now forgive me if you're going so fast, but we're pushed for time. So first thing is to find the y dash. Y dash expression is 3x squared minus 6x minus 9. We make 3x squared minus 6x minus 9 equal to 0. For stationary points, write that out properly, don't be lazy like me. We can take 3 out as a factor here. Minus 2x minus 3 equals 0. And when we divide both sides by 3, we can end up with just x squared minus 2x minus 3 equal to 0. Now I'm going to cut to the chase here. We can factorize this into x minus 3, x plus 1, equals to 0, and either that equals 0 or that equals 0. So x minus 3 equals 0 or x plus 1 equals 0. So our x values are 3 or minus 1. Now we sub those 3 or minus 1 values back into the original, the y equals 1, and we'll find that y equals, just a moment, y equals minus 25 for that point, and 7 for that point. So that means our stationary points are at 3, minus 25, and minus 1, 7. So we'll have to then have a look at the second derivative at each of those x values. These are our x values here and here. Let's check out the y values for the second derivative for each of those x values. So just to get our second derivative expression to start with, 6x minus 6 is our differentiation of our y dash to make our y double dash. Then we'll say when x equals 3, y double dash equals 6 lots of 3 minus 6. 18 minus 6 is 12. So y double dash is greater than 0. Therefore, we have a minimum at the point 3 minus 25. Probably no surprises there. When we sub in, when x equals minus 1, y double dash equals 6 lots of minus 1 minus 6, we get minus 12 there. So y double dash is less than 0, so therefore we have a maximum turning point at minus 1, 7. So we'll come back in the next video and just see how we can put all that information into sketching the curve. So we've found the two stationary points, we've determined their nature, we've got a minimum here and a maximum here, and we'll see what that looks like on a graph in the next little video. Thanks a lot, bye.